Let's just make sure our YouTube studio, we should be going live now. I think we're already live, so you can just start talking, and then I'm going to grab
This is great. I'm gonna do some live coding.
Awesome. So here we go. We got a live stream here. Let me share this out. Here we go. Let's just say on live code professionals at work. Okay, so live coding with Alfredo. And Noah. All right, so we're live here, and yeah, you want to maybe just tell people what we're doing and why we're every Thursday, right around either 8 o'clock or 7 o'clock, one of those Eastern time. We live code every week.
Yeah, so the idea here is that we're getting together, we're doing demoing stuff that we know, that we're showcasing, trying to get a bunch of different knowledge based projects and like shell or web applications, Python, machine learning, all kinds of cool stuff, and we have tons and tons of different topics that we can discuss. And I think today the idea is that we're going to use Visual Studio Code. We're going to do some live sharing, and while Noah is creating this project, I'm going to join in Visual Studio Code and try to follow him and see what this is all about.
Yeah, so what we're going to cover today is an interesting topic, and it's how to create a machine learning application and run it and do predictions. There's a lot of examples of people doing machine learning where it's in a website somewhere in a browser, and then you never get to use it. And one of the problems I think we have today is actually making the stuff work. And so this really gets into the question of, does anything work in terms of machine learning? So what I'm going to do is I'm going to share my code here, and I'm going to give you this example project that is a full end-to-end machine learning project. And if you're curious about it as well, you can just comment on LinkedIn or YouTube or whatever, and we'll give you a link to the project. But in a nutshell, the general structure of a Python-based machine learning project would be, you would want to build a Flask app like you see here. You would want to have the serialized model. In this case, the model is stored as .joblib. But let's say you're using Azure or SageMaker or Google AI platform, and you've trained it in the cloud. You may want to download that model and put it inside of your .joblib is from scikit-learn. But really, I think we're going to see this a lot in 2020, 2021, is many people are going to be downloading machine learning models and putting them somewhere. So that's the other second piece. I think a Docker file is also not a bad thing to include in your project. And in this particular situation, I'm using a Python 3.7 Docker file, and it really doesn't do a ton of stuff other than just package up the application in case I wanted to put it somewhere so someone could use my machine learning application by doing Docker pull, which is pretty powerful, actually, if you think about it. You build a machine learning Flask app, you put the serialized model in there, bundle up in Docker, give it over to somebody's, right? So that's a third component that I would recommend. And then you may want to put your raw data set in here, the one that you use to train the model. I mean, if it's a small data set, or at least sample it, just so that the person that you're dealing with, maybe you're part of a machine learning engineering team at Lyft or Uber or something, or some Fortune 500 company. Not a bad idea to include a sample of the data set that you use to train the model. And then I like to do this as well, which is build out a make prediction shell script that actually will do the prediction for me with the actual curl that I'll run. So this is the JSON payload I would send inside of this Flask app, and these are all features that will serve out a housing prediction. So this is the Boston housing data set, and these are just again different features that you would use to get a prediction. This would work with anything though, right? If it's a classification model, regression model, whatever it is, really, you could take any project on Kaggle, for example, and just tweak it and make it do this. And you can notice here that these are the key takeaways. Is I say content type JSON, and I say the port here. Now I think I'm going to change this to no, I think 8080 is good. We'll leave 8080. The other component that I like to include in a machine learning project is I like to put a makefile together so that it tells people what most likely they would want to do. And these are almost like half suggestion, half commands. And you can see here that a couple things might be interesting to somebody, like, well, look, if I just run make install, once I've created a virtual environment, I can install all my packages. If I want to lint my project, look, I even have some linting for Dockerfile built in here using HadoLint. But these are all some ideas here that someone would use. And then if you want to do advanced stuff, so actually before I get to the advanced stuff, the requirements file here, you can see that I actually pin this project to specific versions of Flask, Pandas, Scikit-learn. And these are really all the three components you would need. This would be maybe like the bare minimum amount of packages for a machine learning project. And I pin them because these particular libraries, especially the scientific libraries, a lot of scientists are really not into building software that works, right? They're building research projects and they're tinkering around with stuff. And so who knows what's going to happen week by week. What you don't want is
Yeah,
for
it's
scientists.
reproducible results, right? Like one of the core
Exactly.
pillars of DevOps, doing
Yeah.
automation and having the ability to do reproducible, getting reproducible results. So like anyone can grab these project and will have the very same versions that you have here. The one thing though that is this is great, but it does take work and effort to go through these and like when you're updating and when you say, oh well, I want to use this new version of Pandas because it's pretty cool, and then you have to come here, update these, and make sure that everything works. But I think that's well worth it.
Yeah. And I think this is we're seeing that a lot of people that are data scientists don't have the skills that a DevOps engineer has, and that one of two things is going to happen: is either the DevOps people are going to start becoming data scientists and machine learning engineers, which I think is going to happen, or the machine learning engineers will also have to pick up DevOps. Both situations, I think, are very good, which is the two things need to merge together and really work as a team. And I don't see any reason why a DevOps person can't also do machine learning engineering. They're very conducive. And then yeah, the other things that I mentioned here, these are just little scripts here, like build Docker files, run Kubernetes, all kind of advanced things that are like maybe nice to haves here. But what I'm going to do to run this thing is I'm going to focus on first walking you through this Flask application and just showing you the key components. So first up, I would put in basic Flask imports here, uh, import as well pandas and then scikit-learn, which are always like kind of boilerplate things to load in. And then this is something that is a little bit confusing at first, but when you're doing machine learning, the majority of machine learning algorithms require you to scale your data. And what this means is that if you're telling someone in a conversation, hey, I ran 40, and you're like, wow, that's impressive. And they think you meant 40 miles, but actually you ran 40 meters. Those are two totally different things, right? 40 meters is basically a sprint, and 40 miles is an ultra marathon. The same thing goes with when you're dealing with data. you have to pre-process it, and that's what the standard scaler does. Is it takes all of the data that's in the columns and it turns them to values between 0 and 1. And so then if you had a column that was my 40-meter times, and then you had my 40-mile times, and you had all of those standardized, they would all be the same magnitude, right? Is that, oh, okay, like now I'm comparing 40-meter times to 40-meter times, and I'm comparing um, you know a 40-mile times 40-mile time. That's really the gist of scaling. Is you're talking about things in the same unit by shrinking them to values between 0 and 1. So most of the time when you do machine learning, you have to do that both on the training and then also on the prediction. Is you want the inputs gotta be scaled as well. So I do have a scale function there, and then I have a route that is a predict route, so slash predict, and then I create a post method, and a post method allows me to accept the payload for the prediction. And I like to actually just put inside of there the payload so that other people can see what it looks like if they're working on my project. And then I also have a prediction here that shows me what it would look like when it's successful. And then really the gist of this is very little amount of code. Is I accept the JSON payload, I log it so that I can debug it when I'm running it in foreground mode. I convert the JSON payload into pandas, which is all that does is turn it into a columnar format, like an Excel format, right? Which is columns and rows. And then I scale the data because, again, remember, to do the prediction, we got to make all the data between 0s and 1s, and then I do the prediction. So it's really just 1, 2, 3, 4 lines of code, and then I return back the JSON results, and that's it. That process is probably going to work for 95% of scikit-learn projects. And then here's the magic piece: is that when Flask first starts up, I take that machine learning model and I load it into memory, right? So it's, in a way, it's kind of like an image file or like a video file or like a Docker file or something. It's just the piece that happens to do the predictions. And I think that's a really powerful thing to know about machine learning models. Is really it's not this mystical thing. It's just another capability that Flask can do now. So how would I run this? Well, the first thing I would do is just make sure I have a virtual environment. So I'm going to say Python 3 -m venv, and I like to create it in the home directory here. So I'll just call the CV or CR, maybe CRD, Container Revolution DevOps, and then I'll source it. Here we go, tilde, and then do bin activate here. Maybe make this a little bit bigger. Yeah, I think the other one was good enough. And then now that I've got this, I'm going to say make install, right? And we know that the make file, in theory, should just put those pin packages here. That's all it's going to
Another
do.
thing is that your Python path also changes, right? So now it's no longer the system Python; it's whatever is coming from the virtual environment.
Exactly.
This is always good to double check. Like, it has happened to me a bunch of times where I think I've activated the virtual environment and I haven't, and and it is the system Python, and that just is all kinds of trouble. But yeah, this is doing which and then calling Python. That's a good way to check.
Yeah, and you could even also put it in here as well, and you can actually tell it um, you can also point the actual Visual Studio Code to have that same interpreter as well, so that when it does like syntax highlighting, it's using the same thing. Um, so I'm going to say make install here. It's going to install it, and then looks pretty straightforward, right? I'm going to look again at this make predictions file here, which is, there we go. So I'm going to say, so I'm going to first run the Flask app. So I'm going to say make, I'm going to say Python app. So let me just double check. Oh, I need to go into the demos directory. So let's go inside of here. Go into Flask scikit-learn, and I'm gonna say Python app.py, and we see that this will run the Flask app in foreground mode on port 8080, or at least it should. There we go, and we can see that it's running. And then what I can do is open up another terminal. I think I can do this right here, right? Is this, yeah, new terminal. So I'm gonna open up a second terminal. And then what this one will do is now I can do a prediction. So if I go back into demos here, I can run that prediction app. So I can say predict, make prediction. There we go. There we go. And so now if I toggle between the two environments, look, you can see that it made that payload. So that's really the big takeaway here. Is
This is where logging becomes really important to always think about ways that you can save yourself from the pain of like figuring out what went wrong. And if you're, of course, this might be like there's all kinds of things that you can do with logging, but like this is where it becomes useful to not only use print statements, because with logging you have all of this the ability to just mute things that you don't want to see. Like this could the level right now it's info, but this could be debug, and then you can change it to no, you know what, I don't want to look at debug messages, and because like I'm fairly certain that this is pretty good. But if you're actually looking into a problem, being able to just use logging, it's a great way.
yeah, and you can see that this does actually really help me understand that. Look, here's my JSON payload. Here's what came in. Here's when it got converted to a data frame. Okay, here's the scale data that goes right here as well, um, and then finally it goes through and it does a prediction. So the logging can be really critical when you're building out a machine learning application. So I think that's the big takeaway that we wanted to show, is that building a relatively production ready machine learning application, if you follow this format, the app file, the serialized model, Docker file, a prediction scripts, in a make file, you're in a requirements file, you're pretty good. You're pretty good to go here, um, and you can build stuff that's very powerful. And I guess you could control some of this as well, Alfredo, right?
I actually like you can see there I just did a request. So I because Noah is sharing the application, I did /learn and it gave me a 404. So and I actually can I wanted to show something where I can go locally and I can do /predict, and I'm in my browser and it will return an error saying method not allowed, because I'm doing a GET request. Like if you copy paste the URL on the web browser, is going to do a GET request. It's just retrieving the information. But Noah has changed or has defined this route in Flask to only allow post requests, and a post request is actually meant to send some data. That's the idea with post. So if he were to change the methods to allow something else, then Flask would allow me to do a GET request. But this is a good way of really narrowing down the scope of what you're allowing, and saving you a headache. But
Yeah.
this
So
is
for
this is
example, like, so if I wanted to make this like a new route and say hippo science is rad, you can see I made a new route, and I can just curl it, and it will it will return back these values right in real time. So that's the other thing that's neat about this, is that I can actually make changes, and the changes in real time I can start making the predictions. And I don't know if anyone knows about hippo science. There's data science, which is you use like math and statistics and You predict things, using science. And then hippo science is, hey, I'm the boss. And guess what? COVID-19 is fake, right? That's hippo science. So sometimes, it's good to be a hippo, especially if you have orange hair. Then it's really good until 2020. Then maybe like you don't get elected again. Anyway, that's my political joke for today. So in a nutshell, good good format here that we showed in terms of building a machine learning application. And anything else you can think of, Alfredo?
This is pretty good. One thing that would be interesting, or perhaps this is a little bit more advanced, is like, at least to me, it's really interesting. Is you're loading, you're loading the I think it's the joblib file when it starts. Yeah. So what happens when the prediction it's too large to fit in memory, like, and you're dealing with something that might not be a good fit for, like, is the answer just get a bunch more of memory, or how can you do this in a way that is not a problem?
Yeah, I think what most likely someone would do in a case of a very expensive prediction. So they call this the inference component. Most people are familiar with the training, right? They're like, oh, I got to get GPUs, I got to train it. But then that's part of it. The other part of it is I have to predict. And with a prediction, sometimes it could be the case that it's very computationally expensive and requires a lot of memory. And so then that's where the cloud systems really do come to play. And that's where something like Azure Machine Learning Studio, AWS SageMaker, Google AI Platform, you could actually create an endpoint that would be scalable and elastic, and it would automatically handle your load. And you could also put the target to be a GPU. So or even a TPU or some other ASIC, like a specialized AI chip. So this is one of the cutting edge components of AI and machine learning right now, is actually how to do the prediction at scale. And a lot of times it would involve specialized hardware and probably a cloud-based component that would do some kind of elastic inference.
That's really good. I really like what I've been seeing lately with Azure, and being able to run and train and get an endpoint at the end is pretty fantastic, and everything's just already there for you.
Yeah, we're working right now on a bunch of top secret machine learning um, engineering uh, stuff on Azure right now with Udacity, and we're in Microsoft actually, and we're working on something that's going to be pretty powerful, and it's going to be released this summer. It's a whole walkthrough of how to do machine learning engineering in the Azure platform and how to scale it, and I think you'll enjoy it. We only work with the best, only the best people. So don't worry, don't worry.
This was great, Noah. Thank you so much for demoing this stuff.
Okay, all right. Well, talk to everybody later. We'll be back next Thursday. Adios.